functionality of the calculator a lot named that. Okay? Alright. It would be fine if you just did tangent and then you did negative pi over 2 and tangent and negative 1.7. If you keep typing it in like that. But if the function gets more complicated, there's a bigger chance of you making a mistake typing the function in. Okay, so I'm going to kind of teach you how around that. Unfortunately, we see the tangent graph, but that's okay. We're going to see it in the calculator bar anyways. So, go to your graph, and I want you to type in tangent of x. Okay? That should be on the calculator. Alright, so tangent of x and hit enter. There's your graph. The older calculators that were black and white and had a lot of pixelation in them, they would actually show the asymptotes in there and look kind of like a heartbeat. Okay? So that's what tangent looks like. Very, very different than sine, cosine, secant, cosecant, right? That's why I kind of separated into the other ones first. Okay? Alright, but we're going to pretend we didn't see that. And we're going to graph it by hand. Okay, so we're going to practice graphing it by hand. But I need to fill out, Mrs. Ballard said, hey, we got to fill out that silly T-chart. I want to do it quickly and accurately. Okay? So, we know that our function is sitting right here in F1. If I'm going to use the functionality calculator to make a lot of calculations quickly. So I'm going to hit this button that says var. That gives me my function where it's typed in. And then I can plug in the parentheses, just like we would do f of 2 or something like that on our paper, and plug in a number and calculate. We use the calculator to do that for us. So our first number was negative pi over 2, so I went negative. My pi, remember, is next to h. And then divided by 2, if you want to do a control divide, you can. And then go ahead and hit enter. All right. Is it okay to be undefined? Look at the graph. I know we can't see them, but what do you think's going on in here? What are they called? What did we have yesterday? Those vertical lines. So if you see an undefined, that's just an indicator of an asymptote. So we know that gave us information about the graph. There's an asymptote at negative pi over 2. Okay? So now I'm going to do it again. Var F1, and I think the negative number was at negative 1.57. Gave us some random stuff, sure. And hit it. So, you're going to write that number down in your T-chart. At least 2 to 3 decimals is probably plain, but I'm not sure if it makes sense when you said negative 1,000, right? I want you to finish filling out your T-chart. So I'm going to stop talking. You're going to work for about 2 minutes here filling out your T-chart. Okay? asymptotes there because those were the two values that came out undefined. And that wasn't surprising. We kind of already saw what the picture looks like. We know they were asymptotes. Okay. Instead of just starting from the left and graphing there, I'm actually going to start from the middle. That's a nice easy point to get, isn't it? So I'm going to start with 0, 0 in the middle. And I'm going to work my way to the left. All right. Negative pi over 4 is got a nice halfway point. So that was really, I might not usually label it, but because it's got something in there for you. Okay. That's why I did even numbers and hash marks. The halfway was nice. So it says that that's a negative 1, so my dot's down here. All right. Negative 1.5, you can only assume, because our graph is scaled different, is somewhere between negative pi over 2 and negative pi over 4, right? So it's somewhere in here. And it says we're down at 14, which isn't even on my graph patch, is it? So somewhere in here, we're down here. And this one gets even worse, right? We're down through the floor, down in the ground somewhere, right? So we're just going to assume we get really, really close to that asymptote. So the bottom half of this graph, we're close to it. We're going to be close to the asymptote, and we're going to curve it up. So it's going to have a concave down. This is what we call that, a concave down line. Opening down, just up to that point. Now I'm going to go the other direction. So at positive pi over 4, which would be the halfway point here, it says we're on the positive point. And then at 1.5 again, we're kind of off the page, right? And then the 1200s up through the ceiling, up off the roof into the sky center, right? So we know we've got it, and this time we're going to curve with a concave up-like curve. So remember when we did cubic graphs? Doesn't it look like a cubic graph? Yeah. The difference is we have periods and it repeats, okay, which we don't have a second period yet, right? We have one period. So we actually have to draw it again. So I'm going to just, all I do to draw a second one, once I have the first one, is I just translate the graph. So I kind of model what I have there and I translate it over. Okay, so I know I went 8 boxes between negative pi over 2 and pi over 2, so I'm going to count 8 boxes here. There we go. Here's my asymptote. I'm going to mark exactly halfway in between on my x-axis. About halfway between that, we were at negative 1. And halfway between on this side, we were at positive 1. That's probably enough to get my curves going right away. Just make sure you see how it kind of looks linear right there. The asymptotes are what's telling you to curve it. Okay, so you have to be careful to make sure you understand that it's a curve. I'm going to go up to my downward curve. Okay. And I don't try to draw it as a single stroke. I usually pick my pen up and do it and then try to do it twice so I get those curves. Not my curves sometimes. It said 2 full periods. If it bothers your eye because the ground patch is not full, you can always add the third one in over here. It's not quite right. So you only have to draw 2. So again, halfway. This little halfway mark, so that was a bit positive 1. The other one was at negative 1. Again, the third one is optional. You really need your graph patch full, but if not, so that was good. We had the calculator assist with it, right? And you know at some point Mrs. Ballard takes the calculator's away and doesn't let you use it, right? You have to have a way to be able to draw it by hand without the calculator, just like we did the other 4 graphs. Okay? And again, this one is the ugliest of them, that's why I kind of saved it for last. I wanted to build your confidence. We have some information we need to fill in. Yours doesn't have a minus C, that's okay. Alright, I'll explain why in a minute. So I'll let you take a minute and fill it in your notes. And we'll talk about it. calculator or Desmos. Okay, I'm not going to torture us with that. It's not a necessary thing to be able to take this to calculate. Okay, so we're only going to work with the VX part. That's why that's what that says. Time period is this right here.
Second between those.
Period is distance. That is the time point. No. It says define period.
Yeah.
Okay, I would just do distance between two consecutive points, or two consecutive asymptotes. That makes sense. Okay, so what we're gonna do is we're gonna count. So on the last couple days we've done period and amplitude, right? Those were kind of the places we started. Well, tangent, because it goes up and down forever and ever and ever, it doesn't have an amplitude. We can't say what the amplitude is because it goes up and down forever and ever and ever. So we can't calculate that. The period is defined as the distance between two consecutive asymptotes. So what we're going to calculate is our asymptotes, because remember those are guides to help us graph. Okay. So what we do is we take whatever's in here, whether it's Vx minus C or it's just your Vx. We're going to set that equal to negative pi over 2 and pi over 2. Which if you think about it, weren't those where asymptotes were on the parent graph? Okay, so that's why we're using those numbers, right? The x-intercept is the midpoint between the consecutive asymptotes. So if I looked at that again, exactly halfway between, we plot our x-asymptote, okay? And then we pick one number in each direction and just make sure we're tilting the graph the right way, okay? So, let's talk about its amplitude here for tangent. Ready? Okay. So, the first thing I need to do is I need to calculate my asymptotes. Okay? So I take whatever's here in the middle and I set it equal to negative pi over 2. And then pi over 2. So x over 2. Sorry. X over 2 equals pi over 2. Those are the two original asymptotes that we've got to kind of scale. Okay, how do I move these denominator 2's from the left side to the right side? I heard it, multiply, right? What's going to happen with those 2's then? Yeah, so we're going to have that at x, our asymptotes are at x equals negative pi and x equals pi. The nice thing about this, it still has that symmetry to it that the other ones have. Okay? So it should be symmetric, the same number but opposite signs. Okay? Alright, so I know that at negative pi, so I'm going to fill that into my t-chart here. I'm still going to use the t-chart assist. So negative pi and pi, and I know that those are in fact undefined. And again, I can scale my graph however I want to. Okay? I'm going to choose on this one to go out 4 in each direction. Okay? So I'm going to go out here 4, and I'm going to label that as pi. Again, an even number is nice because it divides in half. The number of boxes is nice because it divides in half. Nice. Okay? If I wanted to do 3 boxes, I could. If I wanted to do 6 boxes, however many you want, as long as it's understand. Okay? All right. Halfway in between is our midpoint, right? Halfway between negative pi and positive pi, what number is there? Between negative pi and positive pi. Look at your graph, count exactly halfway in between what we have. It's purposely set up to be at the origin, right? And our number is actually already filled into our table for us. That was really nice. I won't have to. I will have to figure that out on your own. Alright. The next thing I want to calculate is I want to calculate one value to the left and one value to the right to make sure I know if I have an increasing graph or a decreasing graph. Okay? So it's really, the shape is the same every time. So what is exactly halfway, because that's a good mark, between 0 and pi? There you go, pi over 2. use those values, we're going to plug them in here to our function, which we used our calculator for before, but this shouldn't be too bad knowing you to circle stuff by hand. Okay? So I know you don't necessarily have to get the circles out. It's okay. I'll help you out. Alright, so we've got tangent of negative pi over 2 divided by 2. Okay, so I put that, I plug that in there. What do we not like about this? What do I have to do? Yep, we gotta flip through a circle. So I've got negative pi over 2 times 1/2. So I really have the negative tangent of negative pi over what? 4. Good job. Okay. Well, if I think about the unit circle, negative pi over 4 is a directional thing. It's on that mark right there, right? So it's going to be negative, sorry, not negative, positive square root of 2 over 2. Right, negative square root of 2 over 2 is my coordinate. Okay? Tangent is the sine divided by the cosine. And so I really get that, and again, I'm doing a lot of chicken scratch work here, right? So negative square root of 2. Okay, negative square root of 2 over 2, and then square root of 2 over 2. What's that reduced to? Negative 1, so that's what I put in my chart. Alright, I'm going to kind of cheat up the next one here. So, now I've got to put in a positive 2, right? Or positive pi over 2. The only thing that's really going to change is some signs, isn't it? So up here, the coordinate is square root of 2 over 2 square root of 2 over 2, so I just change it to a positive sign, right? So that's going to reduce to positive 1. Okay? Alright, so I'm going to plot those. I know that this one is at negative 1, pi over 2 is at positive 1. As close as I can, curve it upside down. As I can, curve it right side up. And let's see, out 8 would have been very good. I don't have to go this way, do I? Go the other way. That one kind of looks like that. I could have gone this way instead. Pick one direction. Okay. What happened? Alright. Okay, I'm going to stick to the order. I did it out of order last period, but I'm going to stick to the order that's in your notes because I want to make sure we get through a full cotangent before we take you guys have to take this. Okay? As long as I would pick your spaces for the middle, as long as you scale it, you can scale it however you want. That makes sense. I stuck with even numbers so I could divide things in half. And I can see where I'm dividing it in half. Does that make sense? If I wanted to, could I have done a mountain 2 in each direction and then that divides it half really well? If I didn't care about the hash marks, I could just do it in each direction. Our graph really goes nicely together. Just depends. As long as you're telling me your scale, it doesn't matter. Right? Alright, let's look at your exam, or actually that was what should have been there and isn't typed in. So put this in the left-hand column real quick. You gotta talk cotangent. I want to make sure I squeeze this in before you guys leave. very similar to sine. You have the same characteristics. You've got to get your asymptotes first. Okay. The halfway point in between, the midpoint is still what's going to be. It has still be halfway in between your asymptotes. And I know we didn't write those characteristics down. But you notice how this middle section here is now equal to two different things. It's equal to 0 and pi. So that's the big change. And why these are kind of a pain. I saved them for the last day because it's not the same as tangent. You have to remember something new. Okay. All right. So we're just going to start by graphing the parent graph. Yours shouldn't have 0, 0 in the middle. Is that right? Okay, so you shouldn't have 0, 0 in the middle. It's not going to be 0, 0. It's a type. All right, so I'm going to start just like I did the others. I'm going to graph my asymptotes. I'm going to take whatever's here and set it equal to 0 and to pi. Because that's what those two formulas told us. So on one part of on the one end, I'm going to put 0 and I'm going to put undefined. The other half is going to put pi and I'm going to put undefined. So if I have 0 on an end, it definitely cannot be in the middle. All right, and then we're going to go ahead and we're going to graph those asymptotes. Okay. So I'm going to choose to use a spacing of 4. Okay, for my in-between here. So I've got an asymptote there and an asymptote here, and I'm going to label them. That was our labeled 0, and we'll label this one pi. How many hash marks or spaces in between when I put my midpoint? 2, good. What would be the number on my midpoint there? Pi over 2, which is important because I need some other numbers for calculation. That's definitely the center part of my T-chart there. Sideways, horizontal T-chart. Okay. Now, I need to pick a number to the left and a number to the right to make sure I know which direction this is tilting, whether it's an increasing or a decreasing motion. Okay? What's halfway between pi over 2 and 0? Good. There's a little bit of a way to use your unit circle to kind of fudge that result. Okay? So, what's wrong? Yes, pi over 4, sorry, I didn't ready to go. Alright. Remember, I have to read yours, right? So, it's only fair. Right? Mine's way worse probably on this than all of my board writing is. Either way, it's not good. Because I write so much, you just Alright, so if you think about it and you're looking at unit circle, isn't that red mark on the unit circle halfway in between? So if you needed a little bit of a unit circle assist, you could do that. Okay? So when I think about in between the other ones on my unit circle, I still want the red mark right there. If I was reading that red mark, it's still an over 4, because our guess over 4. Think about this. 1, 2. What would that one be? 3 pi over 4 would be my halfway in between here. Okay? Sorry. Okay. Alright, so pi over 4, I'm going to plug that into cotangent there. So I'm really doing is calculating the cotangent of pi over 4. And we got square root of 2 over 2 and square root of 2 over 2. Cotangent is the cosine divided by the sine. Hopefully I don't need to write that out. So I get square root of 2 over 2 divided by square root of 2 over 2. What's that? I heard it. Somebody said it. 1, right? So I know that at pi over 4, I am up 1. Interesting. Looks like it's going to come down this time, right? Instead of going up. Alright, I'm going to cheat again a little bit. I'm just going to put a 3 in front there. So cotangent of 3 pi over 4 is over here. The big difference is now I get a negative in front. So I get square root of 2 over 2 and negative square root of 2 over 2. What does that reduce to? Negative 1. So now I'm going to be down here. And again, it has some origin symmetry going on. Okay. All right. We're going to go ahead. This one, I don't know what it is, but I find this one harder to draw for some reason. Maybe it's probably just me. All right, so I'm going to come down direction I picked. If you want to pull the whole graph patch up, you can. I translated over. Okay. If it bothers you, the graph patch isn't full, you just look the other direction. So if you take a look at where tangent was and cotangent was, it wasn't tangent nicely on the origin there, and cotangent shifted a little bit off the origin. You can't depend on the increasing, decreasing. If I went back here to this one, that one, what do you think would happen if I put a negative in front of this thing? It's going to go to a decreasing graph. It's going to look this direction. Don't copy my right. No, it's not even left and right. It's going to go that direction, and now it looks like what we just did for cotangent, right? So that's where tangent and cotangent are really hard to tell the difference. It's always safest, pick a point and plug it into the formula. You're looking at tangent, cotangent. Okay? All right, I know we've only got a couple minutes. Let's see if we can get through one more problem. So part of the problem, at least.
Good morning, hi. This is Angelique and this is Keandra. Please stand and pledge allegiance. Ready, begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay, the homework's posted.
March 26th.
If you need more graph paper patches, I got it back here.
Information forms are available in ASP and up the stage at lunch.